Hello guys, welcome back to the channel, and today we are going to start with the third module, which is getting started with Google Generative AI using the Gen AI SDK. So let's just start the lab. This is another big lab of 1 hour. Click right click and open the link in incognito mode. It will take a few minutes. Then click on I understand. It will be loading for a few seconds and then you will see something like this. Just click on I agree and continue. Alright, now let's just see what is task 1. So first, navigation menu, Vertex AI Workbench. Let's open the Workbench again in the notebooks. Workbench. It will take a few moments. Alright, you'll see this Open Jupyter Lab button. Just click on that. The Jupyter Lab will be loading for few seconds or minutes. If you do not see notebooks in Jupyter Lab, please follow these additional steps to reset the instance, which is you have to close this tab and click on the checkbox over here and just click on restart. For now, I don't have any problem with the lab, so I haven't restarted it, but if you get any problems, you do restart it. Alright. Now in task 2 we have to open into Gen AI SDK. So this is what we have to open. This is the notebook. Let's select the kernel as Python 3. Alright, this is done. Now we just have to start getting started and input all the libraries from here. Alright, shift enter to run the cell. We are just upgrading and installing all the libraries. Now we'll just need to imported successfully. We may need to restart kernel, but okay, they didn't give us any command to restart the kernel. I already selected a kernel. Alright, it's cool for now. Let's see, we have already imported the libraries as well. So just run the cells, and over here don't forget to copy your project ID. Even though they have given your project ID over here, alright, you just have to give your project ID, which is good that they have already given it over here, so it is same. And okay, run this. Before running, if look for anything like location, if there's mention. So Google Cloud region global. Alright, so they haven't mentioned location over here. They haven't even given any location over here, so we are good to go. Just shift enter and again shift enter. Now we have to choose a model which is Gemini 2.5 Flash. Previously we were using 2.0 Flash. Now we have upgraded to 2.5, so it's a good thing. Now we'll have to use generate content again. We were using it previously, but now we are using it as a method, and now in this what we're giving is the model with like the parameters are model and content. So in content, what's the largest planet in our solar system, and it will just give us a text response because we have given the response.text, so we'll get a text response that the largest planet in our solar system is Jupiter. These two asterisk means maybe it is trying to display it in bold, Optionally, you can display the response in a markdown. So if you, I don't know how to do this. Okay, after running this cell, if there is any option to just specifically turning the cell into markdown, then it's fine, but otherwise you will get it in bold. All right. Alright, okay, here's the code for turning the cell into markdown that we did it, which is now you can see the Jupyter in bold, right? Now send multimodal prompts. You can include text, PDF documents, images, audio, and video in your prompt request and get the text or code responses. For more examples of multimodal use case, refer this notebook. They have linked another notebook for that. If you want, just click on it and you will go to a GitHub repository of intro multimodal use cases .ipy notebook, and you can just download it from here and run it by yourself or just read it out. You'll get to know about it. But for now, we'll just stick to this notebook and we'll run this code. In this, they have given a link of a meal image and ask the model that write a short and engaging blog post about this picture. So it has written it in a blog post, like it has given short summary about it and in a blog style. So you can also pass the URL in part dot from URL in the request to the model directly. So you can either use this like image.open and then request.get and then pass the link and stream is equal to true and keep it raw. Otherwise you can also use as part dot from URL and give the URL and mime type as you need, and then you can pass the prompt as well. This is a same thing. You will get a similar kind of response for this because we are doing the same thing, passing the same image just in a different method. All right, so see, it is similar, like unlock your week the power of healthy and delicious meal prep. Over here the power unlock your week the power of meal prep for delicious stress-free meals. So it is similar, not exactly same, because LLMs don't usually give the exactly same answer. They give a similar answer to the same prompt to same questions. So over that is what happening. Now we are going to set instructions. So set system instructions basically. So if you have done the first prompt to Vertex AI course, then you will know what system instructions are basically, and we did them in a different section or segment, we can say. It was not in the Workbench. We did them manually, or like it wasn't in a notebook. So this is how you have to code. Like here we are giving system instructions, like you are a helpful language translator. Your mission is to translate text in English to French. This is the instruction we have given. Now the prompt is user input. I like bagels. So translate English to French is the work of the model. We have given that as a system instruction. So now in the response section, we are passing out the model ID, which is the Gemini 2.5. Then we are passing prompt and contents, and config. We are and in config we are passing generate content config, where system instructions are what we have given over here, and then the response would be in text. So This is French. I don't know French, so I don't know how to pronounce this, but sure. Alright. Next is config model parameters. So you can include parameter values in each cell, in each call, in each call that you send to a model to control how the model generates a response. Learn more about experimenting with parameters. You can click on the link to learn more about them. So over here, again, the content, instead of prompt, we are just passing directly the content as tell me how the internet works, but pretend I am a puppy who only understands squeaky toys. Okay, so it is an interesting prompt. And the temperature basically means the level of creativity you can increase or decrease. And all these things, if you want to understand, like, click on this link, and here's the experiment with parameters values. Here they have explained each and every parameter, like all 4 of these are mentioned over here, which we are using in this uh, notebook. So let's just run it directly. If you want to understand them, do visit this uh, link, and you will have to explore also, because there's just 4 parameters mentioned over here, but you'll have to explore this whole page, and you will find different parameters and their meanings in URL context, in video generation, in image generation. The and there's also safety, which we previously used in our previous modules as well as previous courses. All right, so the response is woof woof, okay, little fluff. It's funny. So it has explained it in a creative manner as we asked it to do. Right, now, configure safety filters. The Gemini API provides safety filters that you can adjust across multiple filter categories to restrict or allow certain type of content. You can use these filters to adjust what's appropriate for your use case. So you can watch here all the safety filters. All right, prohibited content, blocked reason, unspecified others, and here more filters are there. We might have used not currently we have used sexually explicit, and there was one more feature I remember. Yes, harm block threshold unspecified or something threshold was there. So here all the meaning of those things, like sexually explicit means contains references to sexual acts or other lived content. All right, so that is the thing. Like, if you want to understand about safety rules which we are using over here, see, we are using different safety settings over here. So each and every settings will be in this safety and content filters. Again, if you're on this, it is the same page only. Just in safety, there are various safeties. Text and code generation, there are various methods over there. So I would say that do visit for sure. Like, this is an important documentation page where most of the parameters we are using in this notebook are mentioned over there and explained it very well. Alright, write a list of 2 disrespectful things that I might say to the universe after stabbing my toe in the dark. So in this, they have given a lot of safety settings about whether it be sexually explicit, whether it be hate speech, whether it be harassment or dangerous content, anything. We have given block low and above. So according to me, when block low and above means the least, you don't have to provoke it or anything. Here there must be block low and above. So block when the probability score of sensitives witty score is low, medium or high. severity score. Sorry, severity score is low, medium, or high. So it will basically check the severity score and block all these uh, severe uh, contents. All right. So you are passing all these things and will get the response in a very safe manner, rather than weird, or when we are saying disrespectful, so it might give something offensive to the user which we don't need. So real mature universe, it is that the best you can do to prove your existence, because my tool like a word with your divine plan. And that these are fine. Also we can uh print the safety setting safety ratings. So here are the safety ratings which we get for each of the uh, for each of the safety setting we gave in the previous prompt over here. So here are the safety ratings, like probability score is there and severity score is there. Now start a multi-turn chat. Now your system instructions are: you are an expert software developer and a helpful coding assistant. You are able to generate high quality codes in any programming language. These are the system instructions. You have given temperature 0.5. Now we can ask it to write a function that checks if year is a leap year. Alright. And then another is, okay, write a unit test of the generator function. Okay. Unit test. Alright. So this is the Python function which it has given, and it has also explained it what we are doing over here. It has also used example, and here's the proper explanation, entire explanation for the code. You can copy paste this code in a Python file .py and run it to see the output. Cool. Now we have to get this response. Let's see what it gives. It will take a few minutes. All right. Great. Writing unit test is a crucial step for ensuring code correctness. So it is giving how I'll provide unit test by Python's built-in unit test. Mm, So basically, it is testing the framework. This comprehensive set of tests cover all the rules and potential edge cases for the is leap year function, giving you confidence in its correctness. So basically, why we asked to test it, that there are many things like uh divisible by 4, not by 100. So like in the previous code, if the leap year, there's some basic methods which we use for leap year, which is divisible 4 and not by 100, or divisible by 400. And these are all the arguments which we generally use to get the leap year. So we are testing over here that if the code is correct or not about any specific leap year, which is actually a leap year, but it's giving it as not a leap year. So we are testing it over here using the unit tests. All right. Now let's go to control generated output. The control generation capability in Gemini API allows you to constrain the model output to a structured format. You can provide the schema by Pydantic model or the JSON string. All right, now just we are using the Pydantic basic base model, where we are giving name, description, ingredients, and now we'll just give this as a prompt, list a few popular cookie recipes and the ingredients, and ask it to store in a JSON file. Just run it. Optionally, you can pass the response string to JSON. So this is the JSON format. Here basically we have got the name of the cookie, description of the cookie, and all the ingredients for that cookie. Then if we use it over here, then we will just get it in a proper structured JSON format, that the name, description, and ingredients. You can define the response schema in Python dictionary. You can only use the supported fields as listed below. All other fields are ignored. Alright, in this example, you instruct the model to analyze product review data, extract key entities, perform sentiment classification, multiple choices, provide additional explanation, and output the results in JSON format. So over here, we have given a schema of an array, then item will be again array, then this would be an object where we are giving dictionaries of rating, flavor, then sentiment, positive, negative, neutral, explanation dictionary, and require rating. So these are arrays of dictionary, like. And now the prompt is analyze the following product reviews, output the sentiment classification, give an explanation. Absolutely loved it. Best ice cream I have ever had. Rating 4. Flavor strawberry cheesecake. Quite good but a bit too sweet for my taste. Rating 1. Flavor mango tango. So we have given these two uh, flavors, and we are going to store it in this response schema, and we'll just ask it to display in JSON format. So basically it is storing JSON, but it is giving it in a text method. That is why we are getting it like this. And when we tried this similar thing over here, we were just storing that in the JSON response, and we were printing it in a JSON format. Alright, so this is also done. Now generate content stream. By default, the model returns a response after completing the entire generation process. You can also generate content stream, use this method to stream the response as it is being generated, and the model will return chunks of the response as soon as they get generated. So uh, basically you got the idea, right? That we are we get the entire response after it is generated. We just get the entire response, but over here when we use the stream method, we'll get the chunks as well. Like whatever chunks are getting generated, we'll just get the response. Like tell me a story about lonely robot who finds friendship in a most unexpected place. If you run this 2 3 times, you will definitely get a different story. Some might be similar, but yeah, definitely a different story from you. But if you see like the hey, so see, that is why we have put we have printed the stars over here to get to know that what chunks are getting generated in one go. So these are the chunks we get in one go. Then these are few lines we get in the second. So when we are printing something like this, it was giving us a direct output, or something which we previously did was this code and this explanation and all. So over here it directly gave us the entire output in one specific format. Like here you can read it properly, but sometimes when you need chunks, just specific details, then you can use this method which is called generate content stream. So where you will get the chunks. So when you're debugging something, you will get to know that what chunks are being printed, in what way they are being printed and all. You can even use the configurations like when we are setting the tokens like max tokens and all. So this thing helps in that way, that here you will get to know that which points will be removed if you just uh, increase or decrease the tokens. So that is why this is very helpful. Then next is send asynchronous request. I think we have done all this, but in a different way, like not in a notebook. We did it in Google Cloud Console only. So this is the coding function, coding method. So over here we are using asynchronous method, which is client.aio module. This module exposes all the analogs async methods that are available on client. For example, uh, we are using this method, compose a song about the adventures of time traveling squirrel. So let's run this and let's see what it gives. Until it's running, we can just um, look for the time. Okay. Alright, so this is verse 1, this is verse, this is chorus, this is verse 2, again chorus, verse 3, bridge, outro. It's cool. Basically what we are doing over here is that client.aio models generate content is a async version of client.models generate content. So it asyncs the already created model. Now you can count the tokens. What's the highest mountain in Africa? So these are the total tokens we are using is 9. Alright, then compute tokens. So these are the token IDs of every thing, like what what then quotient, then is the longest, and 6 more items. So these are the tokens and their token IDs are there, and this is the length of the tokens. Now function calling, which we have previously did, so I'm not going to explain it in detail again. So basically we are just calling these functions. We created it given a name, description and parameters. Now as a tool we are just declaring that functions which we created, and when we are asking for the model, like anything, like now we created get destination, so I would like to travel to Paris, so it will get the destination and it will show the function we called. It will show the function which we created right now. Destination will be Paris and the name of the function. Now context caching. Context caching lets you store frequently used input tokens in a dedicated cache and reference them for subsequent requests, eliminating the need to repeatedly pass the same set of tokens to a model. So let's just see this. Create a cache. Here you are giving some system instructions. You are an expert researcher who has years of experience in conducting systematic literature surveys and meta-analysis of different topics. You pride yourself on incredible accuracy and attention to detail. You always stick to the facts in the source provided and never make up few new facts. Now look at the research paper below and answer the following questions in 1 or 2 sentences. We are giving the PDF links mentioning the type of the PDF. Again, these are two research papers we have given. Model is mentioned over here. Oh, create cache config, and let's see what we get as an output. Alright, we came across a error. Let's see. Invalid argument. Invalid input data. Please check if the video data is valid. Status is invalid. So it shouldn't be getting any error. I think like we haven't passed any video data, right? We have just passed. We, we give PDF as a response, right? Let's see. Let's just run it. Obviously, we won't get any response because cache content is not defined because it didn't run over here. Just go back to our manual. Then this part. We also done this part, so now we use the function called create cache session, use cache and delete cache. Over here, continuous string lets you store frequently used input tokens in a dedicated cache. Reference we presently passing up. Alright, I don't know what the error was, but after we ran it again, it executed. So we'll just try to run this. Sometimes that happens in programming that you don't know the error. What's the error? You just rerun the code and it executes. That is a fun part about programming. Okay, let's see the response over here. This. So what we did over here was we created a cache. We gave a few PDFs to the module and stored it in cached content, and also gave this system instructions. And now we are using that same cache over here, like cached content equal to cached content dot name. So we are using the same cached content over here because we asked it that what's the research goal shared by these research paper. So it will give us the response properly. Otherwise it wouldn't have got what we are talking about. So we have to keep it as a what we can say, like this was a basic context of the this line is basically the context for the model, that the previous PDFs is what I am talking about, not something else. So it got to know that and it gave us the output. Now here we are going to delete that cache using this caches.delete method, and we have to just pass the name of the cache. Now deleted cache. Okay, now there is batch prediction. Let me see. There's nothing much about batch prediction. Okay, there is. Sorry. different from getting online, getting online responses. So we have 20 minutes left. So different from getting online synchronous responses where you are limited to one input request at a time. Batch predictions from Gemini API and Vertex AI allow you to send a large number of requests to Gemini in a single batch request. Then the model responds asynchronously populate to your storage output location and cloud storage or BigQuery. Batch predictions are generally more efficient and cost efficient than online predictions when processing a large number of inputs that are not latency sensitive. So over here we are going to prepare a batch inputs. This is a location, this is the file format, and we'll just create the input data. Alright, now in prepare batch output location. So here is the given examples and explanation of the output location. So alright, when a batch predicts a predict task completes, the output is stored in the location that you specified your request. Location is in format of cloud storage or BigQuery URL prefer. For example, this. If not specified, something like this will be used for cloud storage and BigQuery will be used for BigQuery storage. This tutorial uses a cloud storage bucket as an example for the output location. You can specify the URL of cloud storage bucket in bucket URL, or if it not specified, a new cloud storage bucket in the form of this will be created for you. So let's see if we can run it over like this only. So yes, it's creating for us. It created a bucket for us. Now we are going to send prediction requests, which is like this, where we created batch and pass the bucket URL to it. So print out the job status and other properties you can use. You can also check the status in the cloud storage console over here. I don't have much time, so I'm just running all these cells. This is optional, you can do it if you want, otherwise it's fine. These are all the prediction jobs in the project. So wait for the batch prediction job to complete. Depending on, so just job has failed. I don't know, it should have been failed, or let's just try again. I guess it just fails. Let's look into the manual. It may take up to 10 minutes for batch prediction to complete. I seriously don't know this part. And also the status. We ran this right. I think it should respond in a complete way. Like it should have given the completed as a response, but it hasn't. So I just try to. Okay. Actually, I'm really sorry I didn't get this part pretty accurately. I don't know why it's getting failed, but uh, after running all the cells over here, mm, when I just click for check my progress button, okay, here's one more. So I'm getting the green deck. So I'm not sure what is happening exactly over here. Mm, but that's actually, I don't have much time as well. That's why I just try to run quickly. Mm, So these are the example output that how it will look about the batch prediction result, retrieve batch prediction result, and over here when we run, we just created this df, but when we asked to display, it didn't display it to us. I don't know what is the problem exactly, but it should have displayed if the job status succeeded. So our job status failed, so that is why it is not displaying the JSON file. I, I seriously don't know why it is not succeeded. Mm, There might be some error, or we just have to pass some of these things which I haven't passed. That might be the issue, but it is mentioned over here that if it is not specified, the bucket will make its own format. It will just use this project ID and timestamp as the format. So that might be the issue. Then we are doing the text embedding. We are using Gemini embedding 001 model, and basically this is what text embedding is. Embedding is basically converting text into numbers of vectors. Vector basically is a number format from 0 to 1. These are all the vectors which you get for the values we have passed on. For this entire sentence, these are the uh, embeddings, I would say. And we have given the dimensionality of 128. So these are 128 dimensions. Like we know x, y, z in the graph, like which is the three-dimensional graph, which is x, y, and z. But over here we have given 128 dimensions as an output, so the values can go and up to that or more than that as well. And that is what embedding helps to understand the relationship between the sentences. So this is what embedding is, and it will be helpful for us when we are doing the RAG concepts. For now I think we are done. Let's just go to task 1 and click check my progress buttons everywhere. Task 2 is done, task 3, task 4, task 5, task 6. Alright, 5 is done, 6 is done. This one is loading. Batch prediction is done. Alright. Basically, you just have to run all the cells. I was just explaining, that is why it took a lot of time of mine. But if you just run all the cells, you will be done within 15 to 20 minutes, because it will eventually take more time over here only. Here somewhere when we created this caching, where we created that cache. Yes, this. Here it will take more time in the entire lab. So that's it, guys. You can now close the incognito window and end the lab. Hope you like this video. Do like, share and subscribe to my channel. See you in the next one. Thank you.